Web3 TV.
Today we have truly amazing speakers. We're lucky to have Cambridge PhD researchers. We're lucky to have Alex, who is a mentor in Techstars, and also the tokenomics guru, and he helped his projects raise more than $100 million. So you're lucky to be here and live with the best insights possible. And usually the experience shows that the less people you have, the more quality conversations you get. So we're about to start. And the first conversation will be led by Vatsal Raina, CTO of Apta AI, as well as Piotr Molenda, AI ML engineer. So guys, welcome on the stage, and I'm sure you will deliver the best speech ever, as always.
Thanks, Nadia. Okay, thanks for coming, everyone. So as the first presentation, we want to talk to you through how agentic architectures drive the scalability of AI-powered crypto products. So that's quite a bit of a mouthful. So the next 20 minutes or so, I hope to kind of break this down into what it really means. And what we're really aiming for is try to give an insight from a technical perspective of how, in this new era of AI and crypto, how companies can effectively build very scalable agentic architectures by using something we call preemptive agentic architectures. And to do this, I want to specifically go through our product called Satoshi, which leverages this technology. Just very briefly, Satoshi is this kind of one-point access to all your crypto needs, which means you can use natural language to effectively access very deep insights in the crypto domain. So kind of like the ChatGPT for crypto, but far, far deeper, more analytical, and very specific to the crypto domain. Just a very brief background about me and Peter. We're both from Apta, which is an AI spin-out from the University of Cambridge. And what we specialize in is building what we call domain-specific co-pilots. So that means we take a specific domain and allow a user to be able to extract deep insights in that specific domain. And as we hear today, the domain of interest, as you can guess, is the crypto domain. And we've partnered for the crypto domain with Hero. And together we're collaborating to build, as I'm going to discuss, Satoshi. So let's just quickly take a look at the scope of what we're going to talk about today. So some of you will already be familiar with this, but I want to spend a tiny bit of time going through the background of LLMs, as this is the foundation of the technology that we're all very familiar with today. And once we've covered the background and make sure we're all on the same page in terms of terminology, I want to take a look at how these LLMs tend to be extended using something called agentic flow. This is kind of the current paradigm used by most generalist AI agentic architectures that many of you probably encounter day to day, like ChatGPT, Claude, Gemini, and many others. Once we take a look at that, I want to highlight some of the limitations of this general agentic architecture, because it's great for a versatile number of purposes, but when you focus on certain domains, it has some limitations, which our product, Satoshi, aimed to leverage and address these limitations directly to be able to build something which is very domain specific and directly addresses people's needs in the crypto field. Okay, so let's take a look at the background itself. So keeping it brief, I don't want to go too technical. The history of NLP has been quite long, but sparse at the same time. It started back in the 1960s when neural networks were first introduced, which effectively enabled a mapping from inputs to outputs. But there wasn't much going on at that time beyond theoretical investigation because of lack of compute resources and even the lack of data to train such systems. So fast forwarding to the 2000s, deep learning kind of resurfaced, which took these neural networks, and now the compute existed and the data existed to be able to train these models for a variety of different tasks. So in the following years, deep learning models were bespokely trained for lots of different tasks, including what we call NLP tasks, natural language processing tasks, including summarization, question answering. And the main point being that these were very disjoint systems. Everyone was training the kind of new novel architecture of how they address these kind of models. But this all kind of changed in 2017 when a paper called Attention is All You Need was released by a guy from Google called Vatsal. And they released this architecture called the transformer architecture, which from then onwards was kind of the foundation of how all NLP models were built and trained. And the first application of this transformer architecture was in 2018 by Google once again when they released this model called BERT. What they really did was they took this transformer architecture and trained it on a huge wealth of publicly available textual data. So they took, for example, all the Wikipedia data and trained this model to understand language itself. But what do I really mean by training it on language data? So all they effectively did was they took a certain sentence from the Wikipedia, masked out a word, and they trained the model to predict what the missing word was. And this pre-training strategy effectively enabled the model to gain a very strong grasp of language itself. It suddenly understood how grammatical sentences formed and how to phrase certain ways that humans tend to write language. And by repeating this process across a huge wealth of textual data, we suddenly had a very strong, what we call, pre-trained language model. And from that point onward, there were several other pre-trained language models which were developed by other groups like T5, Roberta, Albert, GPT-3 even. But all of these models are something we call pre-trained language models. They're very good at language, but they can't actually follow human instructions at this point. They can just understand grammar and they know how things work. What's the most next likely word given its historical sequence of words? So there's a second stage to actually make these models useful, which is called instruction tuning. In instruction tuning, a model like GPT-3 is taken by OpenAI, and they said, okay, we needed to be able to follow a lot of different instructions. So they gave it a huge bunch of different tasks. For example, translate to Turkish, or summarize this text, or rewrite this as a poem. And by training in this manner, the model gained what we call generalist capabilities. Despite having not seen certain tasks at training time, it was able to perform them at inference time, as we say, live. For example, when I asked ChatGPT, can you rephrase this letter? It's never seen this task at training time, and yet is able to do it, kind of like a human, because it's seen a variety of different tasks at training time. So with the advent of ChatGPT, as we all know, there were lots and lots of other instruction-tuned models released, like GPT-4, Llama, Mistral, Gemini, Claude, DeepSeek, and the list goes on as more and more companies compete to try and grab the mind share. Okay, but the story doesn't quite stop here, because instruction-tuned models are great. They can follow human instructions and appear, at least on the surface, to be very clever and do lots of different things. But at the end of the day, these are still language models. And to make them truly useful, the current paradigm is something we call agentic flow, which aims to actually extend the language abilities of these models to far more useful purposes. But what really are the limitations of these LLMs themselves? The main limitations we kind of partition into two groups. One is the modality of the data. The traditional LLMs, not the ones we're talking about, the ones that are used today, the traditional LLMs were only focused on what we call textual data. They were not necessarily able to inherently handle multimodal forms of data, which are particularly useful for enterprises who might have huge databases which need to be queried over, or image information that needs to be queried over, or charts and diagrams that need to be understood. But these LLMs did not inherently understand these different modes of data. The second issue with the traditional LLMs was they were not designed inherently to perform reasoning-based tasks. And the reason was because the way they were trained, they had seen it basically a sentence and they predict the most next likely word in that sentence. It's not doing anything actually intelligent to determine what that next word was. And because of these two limitations, out of the box, traditional LLMs were not particularly useful for many enterprises. So this kind of pushed the whole AI community into an area called agentic flow. So to explain what agentic flow is, I would like to walk you through a simple example. So the main idea being at the high level, the LLM is no longer acting in isolation. It's part of a greater ecosystem of modules. So what we mean by that is because we still think LLMs are great, but they're great at communication. They're not the brain of our system. So the LLM is what it acts as kind of the ears of our system and the mouth of our system. But the brain is done by something we call agents. So let's walk through this simple example to see how that might work. When we ask current AI paradigm systems such as ChatGPT today, what is the weather today? What happens? That goes to the LLM. The LLM, as is the ears of the system, understands the intent of the user. Okay, it says the user is asking something to do with weather and today. And then rather than trying to answer the question directly, it considers what external tools might be useful to answer this question. Nowadays, everyone refers to tools as agents, so I'm going to use the same language at this point. So the LLM decides, okay, I need a location identification agent and I need a weather database reader agent. And the way we're going to do this is, first step I need to do is let me use the IP address or MAC address of the user to identify what's the location, so like a longitude and latitude value. Once we've got these values, let's trigger the weather database reader agent, which takes those longitude and latitude values, passes them to the weather database reader agent, and returns the specific location. And once it's got that information, it returns that back to the LLM, which kind of acts as the combiner, the mouth of our system. It sees, okay, this was the original question. This is what the agents told me. Let me just write it back in a nice way to the user. And this is what we kind of call the agentic flow pipeline, to be able to answer a user's question. So that's great. So now we can handle far, far more complex questions with these generalist systems, because they've got access to what we call these agents to be able to help think beyond the language capabilities of the LLM. But when we focus on certain domains, there are still some limitations. So let's consider, for example, ChatGPT, it's the ChatGPT logo here, as an off-the-shelf model. The issue with the generic agentic flow pipeline is that these systems only have access to generic agents. For example, if you ask ChatGPT who is the president of the United States, it triggers what it calls a web search agent, because this is live information which was not present at its training time. The web search agent is able to search the internet and collect information for the query that you might be interested in. They might also have, for example, a programming-related agent, a Python code agent, to help you handle numerical questions. They can write Python code to be able to execute, to be able to handle more complicated type of queries. They might have different kind of agents to handle multimodal data. We can all use images and videos now with LLMs as well. But the main point being, all of these agents are what we call generic. And we identify three main limitations of the general agentic flow pipeline. One, lack of access to specialized agents. Two, lack of access to domain-specific data. And three, latency for deep insights. So what we mean by that is, let's take a look at this specific example. If someone was, let's say, in the centralized finance space, and they might want to ask a very meaningful question to them. They might ask, okay, what are the attributes of US stocks that have performed the best in August 2024? Let's put ourselves in the position of ChatGPT or any other general agentic architecture and think how it might tackle this question. Based on what I've described so far, the system would be like, okay, I need to understand what the user wants. What they're interested in is identifying the best stocks in August 2024. To tackle this question, I need to trigger some external agents. Which external agents might I need? First, I need to get the data itself. So let me try and find an API that exists somewhere in the internet, which allows me to fetch US stocks data. I will first fetch all the US stocks data and hope first that this API exists. Once I've got all the historical US stocks data, I need to filter it out for August 2024. Once I've filtered it out, now I get to the next step, the hard step. The user has asked me for the best stocks. Now, this is a very ambiguous term. So me as a system has come up with a method of how I define best and create some algorithm to record that metric. Once I've made up some kind of algorithm of how to handle this question, I apply this algorithm to every single stock on the historical prices, and this gives me some kind of ranking, which I can give back to the system. So as you can kind of see in my explanation, it seems a bit far-fetched. It's very, very optimistic for a system to be able to actually do this, because we made several assumptions. One, these very intelligent agents exist, which can come up with this algorithm. Second, that the data is readily available online to be able to do this. And third, even if we live in this utopia, that we can actually get these insights at a reasonable speed. Because doing all these different steps could be in the order of hours, by which time the user would have already left the platform and you would have lost user retention. So at Apta, when we focus on specific domains, we try and address these challenges head on. And to walk you through how we achieve that, I'll hand over to my colleague, Peter.
Great. Thank you, Vatsal, for outlining the challenges of different architectures interfacing with LLMs. And as long as these may be good for what many people call ChatGPT wrappers, simple interfacing systems for basic functionalities, this does not quite scale for Web3 needs across hundreds of chains with very complex data types. So what do we do in Apta about it? We go one step further, and we believe in something that we called preemptive agentic architecture. we partner with a domain expert with a company called Hero to do a lot of research about the interest and the needs of the users in the Web3 space. And we identified 3 key methods, 3 key points to kind of achieve scalability and build a modular system that can go into many directions, many data streams. So first, we focus on collecting, processing, and preparing data specific to Web3. Secondly, we build agents that are capable to interact with all of the appropriate complex data structures in a very efficient manner. And then thirdly, to build on top of the previous 2 points and highlight what's the heart of our idea, is pre-calculating a lot of intermediate steps preemptively for what users might need to achieve latencies that are much better than any other people can achieve in the industry. Okay, so today I will also tell you a little bit more exactly about how the AI Web3 Copilot works to achieve all of those things. At first, I'll give some main principles behind the agents that we're using. Then I'll give you a quick demo of a typical workflow that one might have working with Satoshi. And finally, briefly touch on a roadmap and possible extensions for the future. So we start at the very top. So our idea is for this system to revolutionize the way that we're interacting with content, with research, with data online. We hope, as Vatsal said, this to be a one-point access for all of your Web3 needs. So any question will be first interpreted by LLM, understood the intent, and will be rerouted to different agents based on the identified data that would be needed for the response. So what can be, our agents go kind of along 2 axes, I would say. One of them is in terms of data streams, where we might collect market data, social media content, on-chain data, and plug into those directly. Or they can go along different layers of complexity, where in a basic complexity, they would focus on data availability. On this next level of complexity, they would provide data analytics, and then finally allow execution of different complex tasks. To give you some examples, we may have a market agent, which you can ask for market prices, market cap data, any historical prices, and access them directly. We may have a Twitter agent that you can ask about topics, categories, conversations that are happening in social media, and it would fetch you some highlights, give you the tweets and a feed of posts of what's going on. And then we may have a second layer agent, for example, a KOL validator, which combines posts from Twitter and the historical market data prices, analyzes the assets mentions, the sentiments, and then cross-reference them historically with what are the actual outcome of the prices, telling us are the KOLs that we're listening to reliable in terms of what they're speaking about. So now that we understand the high level of how the whole architecture that we built works, as I said, I'll show you a workflow of what how one might interact with it. So let me see. Perfect. I'll read it out because it's not quite clear. The interface is very similar to ChatGPT. Many people are now familiar with this kind of chat interface and they enjoy this conversation style approach. At the bottom in the window, people can ask any question they want. Here we're starting with a data accessibility for the market. We say which meme coins are more than 80% down, have from their all-time high, and have a market cap of at least 100 million. Maybe that's a category of projects that interests me. And the system responds in a multimodal way, starts with a highlight from the AI, then provides a table with a list of coins and all the relevant data that I've asked kind of in the query. Then I can go scroll even lower and investigate more any of the tokens that in here has been suggested. Look at the prices, look at some metadata, maybe quickly browse that content that are quickly available. Let's say here Floki piqued my attention. So I'm going to go the next step of my investigation and ask for data from social media. Let's say any news about Floki. So again, first the LLM interprets my intent, routes it to the social media agents. In this case, it's going to look for articles and it's going to look for tweets. And again, first we get a highlight from LLM saying what kind of articles have been talking about recently, what tweets has it seen, and then as I said, we really care about reliability and trustworthiness. So we don't just give AI response to trust at the face value. We provide all the sources, all the articles to go deeper into, a whole Twitter feed of all the recent or almost practically live tweets that we access for the specific topic that we ask, so that people can go and verify this response. People can go and do more research if they wish to. So then going into the next step, as I said, of layer 2 analytics agents, I may ask now, okay, so which other coins have had the most increase in mentions of Twitter today? Now imagine doing this with something like ChatGPT. Even if it has technically all the capabilities of it, being able to access millions of tweets at a time, analyze, categorize them, group them, it would be pretty much impossible. In this case, our prepared data streams for tweets and prepared aggregations with analyzed assets and mentions immediately gave me a table with responses. So let's say here I saw that Bitcoin is often talked about the most, especially around token. I'm going to ask another question to see analytical capabilities. Should I buy Bitcoin? In this case, I'm going to get charts with analytics and all of them are pretty much very interactive. That's what we really focus on. We want to provide the data. We want people to see it firsthand and not just get the generic LLM answers. All right. So this is one of the examples of how people might be using Satoshi. It's just a snapshot of a couple agents and a couple functionalities that we offer. And there's a lot of things that we have planned ahead. Right now, I will actually focus mostly at the end for the more long term. I would like to highlight the execution agent and the MCP, where basically, as I said, our systems, just because of the agents that can plug in on different layers of functionality and complexity, as well as plug in directly to different data streams, we can grow and expand along our needs and along our users. Right now, we want to really focus on the data availability and the analytics before we allow our users to pretty much automatically execute trace based on different signals that we might have. So that's why this is an easy growth plan. And then going even a step further, many of you may have heard recently about the term of MCP, which we will probably talk a little bit later in a presentation later in the day. It's a new protocol where LLMs are able to interact with different databases and different points on the internet to allow people to basically create their own agents, create their own systems. So where this is all the work that we're doing right now. This creates a decentralized space where more people can contribute to it and, scale almost infinitely. Yes. So, if anyone is interested right now, Satoshi is actually completely free to use. Sorry. Let me go again. So it's completely free to use. I'm going to show you the QR codes at the end. We want people to try the system out, give us the feedback, see what are the features they really like and they want them to be perfected. What are the features that they think they're missing? It's available on the web app and it's available also on iOS and Google Play. On the App Store and the Google Play. So, feel free, and I hope that now you kind of see how we're planning this to become a Google and Perplexity and ChatGPT and traditional analyst all in one place. All right, thank you.
Thank you, guys. If anyone has any questions, please feel free to ask right now.
Hi, Maciej. I'm from Centralized Exchange, but I used to work with, I would say, before LLMs things. My thesis was connected with neural networks. And I have two questions. One is more from the technical perspective, so probably I need to, maybe we can talk later, but about the Satoshi, because I played around with it probably half of a year ago or something like that. I wonder, okay, I understand the concept with Satoshi, LLMs, etc., but why you need blockchain? What are you, when you are using blockchain for Satoshi? This is something interesting.
Yeah. So just to summarize in a very simple way, we're a Web2 product for a Web3 community. So the way we're using the blockchain is not in a native way. It's basically give information access to be able to give users the ability to query over the blockchain very easily. So this means queries like, okay, who are the top holders of Satoshi right now? Can you tell me what have been the recent transactions of this specific wallet address? Or can you tell me which wallets have made the most profit in the last week? On the Solana blockchain, for example. So you can imagine these type of queries being asked in natural language, which usually would only be reserved for people who have like technical capabilities of how to write maybe SQL queries. They know how to access the blockchain. And what we're really doing is allowing anyone to use natural language to get the information they need. So what I would kind of say is democratizing access to anyone. So I guess the way we're using blockchain is giving people access to be able to query over the blockchain.
Okay, so I understand this part. So in reality, you don't need blockchain. So let's say if we won't have blockchain, you will just be accessing data from other things.
Exactly.
Do you have any plans, because we know how, I don't know, ChatGPT and others are using NVIDIA and things like that. There are more and more like artificial ethics and all the FAT and so on projects that people are providing through blockchain, the access to power. For this type of solutions. Are you planning something like that, or?
So I think if I understand your question correctly, you're talking about decentralized hardware, effectively?
Yeah, for example, decentralized hardware thing somehow, or for example, that people can verify, because one of the problems with ChatGPT, Gemini, or others is that after some time they are getting, if you play around wisely, you can mess the data in reality that they are using. So, for example, you can use blockchain or any other mean, not only for decentralizing hardware, but also to have some government or anything that is verifying that the data is really useful. It's not some stupid data from Twitter or from any other place.
Yeah, so I think you're saying by having some form of decentralization, it acts as a community-led form of validation of the data streams itself. So for now, we're limited to like a Web2 setup in the actual technology itself, even though it's catering for the Web3 community. But I think one thing maybe Peter touched upon is the long vision of having this something called MCP, which I'm not sure maybe Anthropic released in November 2024, where the concept was, okay, it's great we have our own set of agents, but we can't be perfect. We can't invent every single agent in the world, and we can't have access to every single data source that ever exists. What would be more powerful would be that someone else on their own server, some other company, which doesn't want to give their data to us, but has very powerful data, and it wants users to be able to access the data through our platform. If we define a standardization protocol, they could effectively host their own AI agent on their server, keep the data on their server as well for privacy, and just make sure that communication is standardized in our system and their specific AI agentic function. And now our traffic can be routed towards their use case if that's relevant as well. So that's, I think, why it's particularly important in the crypto space, not in the normal AI community, because people really care about privacy.
Okay, thank you guys. Do we have any more questions for the speaker? Okay, so thank you guys.
Thanks, Nadia.
Amazing as always. And I'm really happy to, thank you. I'm really happy to introduce our next speaker, which is Alex, CEO and co-founder of Simplicity Group, also mentor at Sui Hub, at Techstars. He helped our projects at Simplicity to raise more than 100 million in total. And right now he will deliver the amazing speech with a paint presentation.
Thank you so much. Pleasure, everyone. Thank you. So this is our website and a bit about what we've done. Long story short, tokenomics and research, and let's just stop there. But instead of creating a presentation on, PowerPoint like any sane person would do, I thought it'd be a bit more fun to just open up Paint and to do everything on Paint because, sorry, 1 second. Because I feel like there's something nice about not preparing a presentation and just doing this offhand. I realize it's not on this screen, so I'm actually going to have to look this way when I'm doodling, which is great. So the whole point, actually, sorry, I'm just going to grab my phone because I have a bit of a, I didn't prepare, but I do have a little bit of a talking point list. Okay. So the whole point of this presentation is to understand how to align your supply and emissions with your user growth. In essence, as everyone knows, the typical price chart of any token, that was horrendous, but it looks like that. And that's actually quite optimistic because they only went down by about 50% instead of 100. The reason why it looks like that fundamentally is because there is much more supply than there is demand, which is quite an obvious statement. However, for a lot of projects, they don't seem to understand exactly why that happens. So I want to run you guys through an example case. Let's say you have a bigger font size, first and foremost. Maybe you don't. I feel like there's a... okay, there we go. Cool. People can let me know after if I should ever do this again or if I should stick to PowerPoint presentations. But let's say you have a token supply of 10 billion tokens. Just like that. Now, let's say you have a token price of 0.01. That's just something that you decided to do. That means that your fully diluted valuation is $100 million. In essence, a fully diluted valuation is obviously your total token supply multiplied by your token price. Very nice and simple. Now, another point is, let's say when you launch, you have 2% of your supply unlocked, maybe from TG unlocks, from liquidity as well, whatever. So 2%, that means that you have 200 million tokens unlocked. And that puts your initial market cap, which is your circulating supply multiplied by the token price, at $2 million. Now, this is the case for basically every single project ever that's launching nowadays. Their initial market cap is tiny compared to their fully diluted valuation because they have barely any tokens out. Now, I'm going to try and draw this, and please forgive me. Actually, no, I'm going to use straight lines because that's just much better. Go that way, then we'll go this way. And I want to introduce a... why is that white? Hello? What's going on? Sorry, am I... okay, there we go. Introduce a very nice and easy topic to grasp of supply and demand, which is something that you learn in economics. That's not the very first thing, but it's very nice and applicable here. If I can scroll down a little bit. So, let's say this is your demand line, this is your supply line. I'm going to add in the token price over here, and then over here is we have the quantity supplied and quantity demanded, since both of them are on the same chart. This is our demand line, and this is our supply line. So this is economics 101. In essence, this is demand and supply curve. Long story short, where these two lines intersect, that will tell us the price and, of course, the quantity. So the price here is 0.01 and the quantity here is 200 million tokens. Is it 200? Yeah, 200 million tokens. So actually, let me do this as well, just for ease. This over here is your equilibrium price between the price and the quantity. So that's nice and easy to understand. What happens, in essence, is as you unlock more tokens, your supply side, the supply line, rather, shifts to the right. And the way that we can visualize this is by drawing another supply line over here and titling this supply 2. Now, as a very brief kind of tangent, because I have 20 minutes, even though I only need about 10, very brief tangent. Let's pretend I didn't draw that just now. What this means is, the higher the price, the less people will buy it, because, where the price will hit the demand line, it will be a lower quantity. So the higher the price, the less people will buy it. On the flip side, the higher the price, the more the creator, the supplier, the shop, whatever, wants to sell of it. So that's why, interacts with the line here, and that's a higher quantity. The reason why we created a new supply line is because we are now increasing the fundamental amount of supply. We're not just looking at the relationship of price to quantity. Now, when we increase the supply line, for the very fast of you, the new equilibrium is over here, which, as you can see, is a token price which is lower. Now, that is the simplest way of describing what happens when you unlock more tokens and have the same amount of demand. So for example, if you have 1,000 users and they're buying $10 worth of tokens, that's fine when you are at your initial market cap, when you only have 2% of supply. However, when you unlock more tokens, it's not fine anymore. So what you need to do is quite, obvious, if you will, and it's you need to increase your demand, because when you increase the amount of demand that you have, as you can see, the equilibrium price has gone back up to over here. It's gone back up to 1 cent, even though the quantity is much higher. This is supply and demand, and in essence, that is fundamentally, what you need to keep in mind when you're designing your emissions, valuations, and everything else. And an easy way of saying this is actually something else I want to draw. So one good, let me move this out of the way. Just like that. See, this is why I love paint. Okay, I will now explain why exactly this happens, in the sense that why exactly when supply increases but demand doesn't increase, why the price goes down. So here you have price and quantity, as we had before. Actually, no, sorry. Here, this is a different chart. This is the chart that everyone will be familiar with, where you have price on this axis and you have time on this axis, and this is your typical token price charts, which obviously a lot of them look pathetic, but in our case, hopefully it won't. So what happens is, let's say you're still at, your 1 cent. You launch, and for a month, your token goes like that, maybe it comes back down, maybe it comes back up, whatever. You're chilling over here because the amount of supply that you have is the same, because all of your VCs, your team, your clients, not clients, but whoever else you have, your treasury, they all have cliffs, right? They have a 3-month cliff, let's say. Let's say the VCs now have a massive big unlock 3 months in. You have an extra 3% of supply that becomes unlocked. And obviously it's a VC. It's their job to sell the tokens because that's how they make money. So they sell the tokens. What will happen is, let's say they are selling their 3%. I definitely should have used text function instead of doodling this, but whatever. They sell their 3%. Simply put, here at this price, you still have the same amount of demand, right? So maybe, you have your 10,000 users they're buying, they're selling, they're trading, everything's nice and well because they have only 200 million tokens to sell. VCs are now adding another 3%, another 300 million tokens. The users are still the same amount of users. They still have the same amount of buy pressure. So now, when the VC clicks sell, let's assume that they nuke the chart, they sell everything all at once. What will happen is the market makers, whether it's a decentralized market maker or your normal market maker, has a few people that are buying at this price. They have a few people that are buying at this price. They have a few people that are buying at this price, this price, this price. Whether it's limit orders, as in people who said, okay, as soon as price goes here, I want to buy X amount of dollars. Whether it's just people who look at the chart at a particular time and they're like, this is a great price to buy. I'm going to buy right now. So point being, right here, you still have, your same amount of users buying. So they buy the same amount of tokens that they would have bought back here or back here. However, that is nowhere near enough buy pressure to account for the 3% of supply. So your market maker will bring the price down because it will keep looking for people to buy the token until this full 3%, that was pathetic, apologies. So the full 3% is purchased by someone else. And as you can see here, that will be your new price. And that just perfectly matches our second equilibrium. So that is, in essence, pretty much it, to be honest. So the way that you account for your inflation is you do some very quick and easy maths. You open up an Excel sheet, which I won't do today. I'll save you guys the time. You open up an Excel sheet and you do some maths. So let's say, how do I say this? Let's say your users are buying $10 worth of tokens each month because they're paying you some sort of subscription, right? And then you have 1 million users. So therefore that's $10 million worth of buy pressure per month. Let's say you have a churn rate every 6 months, half of them leave, whatever, you can program that into Excel. But you have a set amount of buy pressure each month. All you need to do is just make sure that you have very reasonable projections for growth and you align your vesting schedules and your cliffs with those projections so that as soon as there is a big increase in supply, you pump it up with a big increase in demand. So for example, if there is a 3-month cliff and a lot of VCs are going to sell their tokens, right here is you say, by the way, guys, we're launching on Binance, right? And the demand will increase. And, there's obviously things like product releases, expanding into new markets. anything really. You just align to the best of your ability, your unlocks and your vesting schedules with your growth rate in users. And as long as you don't launch at a stupidly high valuation, because this is ludicrous, right? $100 million, it's insane. The only reason why projects have billion-dollar valuations is because, what can I say legally? Because there's not that many people selling. Let's just go with that. And if you're a normal project, you're not one of those projects that raised $100 million and they put all of that money into liquidity and pumping up the price. Your valuation realistically should be around 6 figures, maybe below 7 figures. That is the fair valuation for the vast majority of projects. The reason why they have such high valuations is purely because they need to fundraise money, and you need to fundraise for some reason millions of dollars. And for that, you need to have higher and higher valuations at each round. And therefore you end up with having a massive valuation when you list, which again is fine initially because you don't have that many tokens. But as soon as more tokens come into the market, your product just doesn't catch up, because as you can see, obviously the difference here is you start at 2%, you have 98% still left. So if you start 2% and you're going sideways, obviously if you have 98% of the supply left, well, you're going to go down pretty much to zero. And that's pretty much it, to be honest. You know, designing your tokenomics so that your growth aligns with your supply isn't the most difficult thing in the world. As you can see, I just doodled it on Paint, but it's just a matter of understanding how many users will be buying the token and how much of the token they will be buying based on your utilities and a lot of other stuff, which I don't think will be interesting to go into now. So that's it. And I want to extend the microphone to anyone if anyone has any questions as a quick Q&A session about tokenomics. Otherwise, I'm done.
Any questions on tokenomics, guys? Okay, good, good. It was the simplest explanation for tokenomics I've ever heard, trust me.
Simplicity Group at its best. Thank you very much.
Yeah, by the way, if you're interested in tokenomics, feel free to follow our Twitter, Simplicity of Apta. We publish research articles, for example, on Hyperliquid. We do ecosystem overviews. We did on Barachain. We did on Tone. We presented it during Tone meetup. So feel free to follow us on socials. And yeah, I'm presenting the last speech for today. Still very insightful. And yeah, please welcome our next speaker.
Thank you. Hi, everyone. I'm currently brainstorming how to beat a Paint presentation.
It's a very, very high bar, isn't it?
It's too cool.
Honestly, after I saw the demo of Satoshi, I was in such awe that I was like, I don't even know what to say to people.
Okay, thanks everyone. Thanks Alex for the last talk, it was very insightful. So in the previous talk before Alex, my colleague Vatsal and Peter already presented to you Apta, so I'm going to keep introductions here very short. I'm Vyas Raina. I look exactly the same as Vatsal because I am his twin brother, but I am the Chief Science Officer here at Apta. So you already know at Apta we are building domain-specific agentic copilots. But just as a really quick reminder, in case you weren't here at the first talk, the first application of our copilot is Satoshi AI, which is your crypto-specific AI copilot. So great. This AI copilot is allowing us to build cutting-edge technology and get it out there in industry. But a question we often get asked when asking about how we scale Satoshi is, how do you keep up in this extremely fast-paced industry with new AI products, new features coming out almost every week? What are you building today to keep you ahead of the AI curve tomorrow? So in a bid to answer this question, today, I'm going to present to you what I believe are the next biggest things in AI research likely to come into industry this year. So there are going to be 4 parts to this presentation. Just as Vatsal did in the previous presentation, I'm going to have an even briefer review of large language models to ensure we are all aligned in our understanding of how they work. But then I will use this as an opportunity to highlight the issue with these models being these extremely large, difficult to control, I would call it these monolithic black box systems. So it's very difficult to control these. So I will show how research on the topic of model steerability offers a promising solution to opening this black box and giving more control to the user. At this point, then, I will switch track and focus more on the issues around scaling. So in the talk at the beginning, you learned that everyone's kind of moved away from relying solely on these LLMs, but using something called the agentic paradigm instead. But I will then show how this agentic paradigm, despite how clever and useful it is, also has its issues and struggles with scaling. And then I will present, as hinted earlier by Peter, Model Context Protocol, MCP, as a solution to this, a new and upcoming protocol, which I believe is going to be very mainstream in AI products even by the end of this year. So without further ado, I'm going to quickly show everyone the same timeline they saw before and remind them that the key focus here is that 2009 is when we had the first deep learning systems. And it's only by 2024 when we have these very powerful models like DeepSeek, ChatGPT, Gemini, with these generalist agentic capabilities. But the point I really want to highlight and everyone to remember is how these models were trained. So you may remember that there are two main stages to training. First, there was something called self-supervised learning. This is what gave the models the ability to understand language well. And second was something called instruction tuning. So shown by examples on the bottom, this is where the language model was given examples of many different question answer pairs for different tasks. So it now knew how to follow human instructions. But there is a problem. Despite models now being much more effective, following human instructions, and there being up to like 1 billion monthly active users of ChatGPT, there is a problem. The problem is, as a human user, when I go and use ChatGPT, I really struggle to make it do exactly what I want it to do. I'm going to illustrate this with an example. So when I was thinking of giving this talk, so I was preparing, and I was thinking, I would start with a simple sentence. I would start by saying, I am attending Token 2049 in Dubai, and I'll have a nice, simple, benign start. But then I thought, I want to make this sentence more humorous, more acceptable by an audience. So I went to ChatGPT, like anyone else would, and asked it to make it funnier. And it did its job. It wrote, I would say, something quite witty. But perhaps it did its job a bit too well, and I thought it wouldn't be appropriate to start this way. So then I asked ChatGPT to make it a little less funny. And again, it did its job, but this time I felt the joke was a bit too weak. So again, I prompted ChatGPT and asked it to make it funnier again. Now, what you can see from this exchange is that it is very difficult for me to control the output of the LLM. In fact, the only way I can control this output is by using my natural language input to influence exactly what I want in the way it phrases its output. And it's not simple to control this, to have the exact level of a particular property, in this case, funniness, as I desire, using just this natural language input. And this is what we call the control problem. We can only control LLMs through the natural language input, and that limits the amount of flexibility we have as a user to get the exact desired output. But luckily in research, there has been some promising work on this, and I'm going to give you an insight into what's being done. So imagine a future where large language models not only accept natural language as an input, it might be blocking the screen, but also accept tunable values at the input of different properties. So, for example, I would be able to set on a scale of 1 to 10 exactly how funny I want the output to be without having to fiddle around with the input prompt to get that desired behavior in the output. Now, I could repeat this for different properties such as casualness or optimism or any other property we care about in the model's output. And in this way, this is how we achieve model controllability. This is what we mean by steering the model behavior in the direction we desire, opening that black box and giving more control to the user. And that's great. So I think I would encourage everyone to look out for these kind of controllable large language models in the future. But the more technical ones amongst us may be wondering, but how can this actually be achieved? You already described to us how large language models worked as these next token predictors, which only accept an input prompt. How can we get this more controllable behavior? So going a bit more technical, there's a very, very brief overview of how we could achieve this. So a large language model effectively consists of two stages. The first stage is an embedder, and the second stage is the rest of the large language model, which I will call a decoder. The embedder is responsible for mapping that natural language input, in this case, the sentence I had, I am attending Token 2049 in Dubai, to what we call a mathematical vector representation. This is what people call an embedding. Now, this has been depicted by the orange arrow on the diagram. This is effectively a vector, which has been shown in a 2D graph, which represents my natural language input. Also in this vector space, there exist certain directions which align with certain concepts, such as casualness or funniness or optimism. So now, if I want to make my output funnier, all I have to do is move my orange arrow more in the funniness direction. And this is what we allow ourselves to manipulate that intermediary stage and get the desired behavior in the output. And that's what gives us this controllable behavior. So great. So I hope this has given a brief insight into how we can achieve this controllable LLM and get these more powerful LLMs to give users more control and open the black box of LLMs. But now I'm going to talk about scalability. In the previous talk, well, not previous talk, before the previous talk, we learned that LLMs are great. They're these probabilistic models, but they've been evolving to become agentic. So this is where you use LLMs as an interface to tools and functions and agents, as opposed to being the go-to or endpoint themselves. But when it comes to scaling these LLMs with this agentic paradigm, when you get more and more agents, when you go from having 100 to 1 million agents, there are issues. And there are issues in how the LLM understands this. So this is what I'm going to go through next. To do this, I'm going to start with an example again. So I arrived in Dubai on 1 a.m. on Monday, and I knew, someone told me, that the Artisan is a very nice restaurant over here. So I thought I would ask ChatGPT whether there's any availability. If I'd asked this question in 2022, ChatGPT would have used its probabilistic head to try and work out whether there's availability. And what this means is that it would literally just choose between yes and no as the words as the output, whether there's availability, without being grounded in any real information. It would effectively look at the training data it has and sees what percentage of the time was the availability in the Artisan and reply that way. And that obviously is not the right way to do things because these kind of information changes dynamically. But the industry as a whole caught on. They realized that we can't use large language models in this probabilistic way, but we have to give them access to agents. So as a very quick reminder of the same diagram you may have seen in the previous slide, but before the Artisan problem, where we're asking about the availability at this restaurant, we are no longer using the large language model to answer the question. We're using the large language model only as the ears of the system and the mouth of the system. So it understands the question, whether there's any availability, and this time routes to different agents. The agents in this case being, again, location identification. It knows I'm in Dubai. And the second case, the restaurant API. So it talks to the restaurant, works out whether there's any availability, returns the information to the large language model, and the language model replies very nicely. Unfortunately, the Artisan is fully booked tonight. So it demonstrates that just relying on the probabilistic model is not the way to go. And the industry as a whole has solved this issue by creating the agentic paradigm. But there are challenges. The agents I showed here was for specifically the restaurant, but that there are thousands of restaurants. There are millions of different kind of applications you want to use a language model for. Especially in Satoshi, there are more than 1 million different crypto companies and products out there which may want to offer their APIs through our platform. How do we scale to this kind of situation? So we identified two main problems when trying to scale this agentic architecture. The first, as shown here, is fragmentation, and the second is privacy. So fragmentation is looking at the problem that as we get more and more tools, each one requires its own bespoke way for the LLM to interact with it. And this confuses the LLM, which makes it very difficult for it to actually effectively use these tools. The second thing is privacy. Many of these tool providers or agent creators don't want their agents to be swallowed by some LLM. They'd rather keep it to themselves and only have some kind of interface with the LLMs. So how do you maintain privacy of agents in this agentic architecture, which everyone is adopting? So these are two main issues, fragmentation and privacy. And we're going to look at solving them next with a concept called Model Context Protocol. So MCP came about first at the end of 2024. It was this idea, it came from Anthropic, the creators of Claude, where they were like, there are so many competitors out there. There's OpenAI, there's Claude, there's Gemini. All of us are making LLMs. All of us are creating our own agents. And also many, many other agents being created by other companies. But our LLMs aren't very good at using these agents because each one is very different. Can we all agree as a community to create a protocol? So those are the initial works in trying to create that protocol. I'm going to discuss what that actually means. So as an overview of the protocol, it tries to address the two problems of fragmentation and privacy head on. First, it has this idea of standardization. So everyone tries to define everything in the same way. And second is decentralized execution, which tries to tackle the issue around scalability and privacy. So let's go to each one of these in detail. So before we actually go into details, remind ourselves of the actual agentic architecture. We have the LLM, which is trying to use a restaurant API. Now, as a restaurant, if I'm going to follow model context protocol, the protocol everyone's going to agree on, I have to agree to the same standard which everyone else uses. What this means is the schema I use to define my tool is going to be the same as any other tool defined by people. This makes it very easy for a large language model to know how to use my tool, which means that if I'm a new restaurant and I define it in this particular way, I don't have to worry about the language model not understanding the nuances of my tool because I've been consistent with the schema and it's aligned with how the model has been trained. And what this really allows is that any number of tools that exist out there, following this schema, can be confident that the language model knows how to use them and also not get confused in their applicability in the use case. Next part of the solution is the decentralized execution. So again, I want you to remind yourselves of this current agentic paradigm and how this agentic paradigm is going to change with decentralization. Watch carefully. You see, we have added a new block. What's happened here is now the large language model doesn't directly interact with a restaurant API. Instead, it interacts with something called the MCP server. So what this MCP server is a restaurant will host its own machine, which does all its own calling to its own database. So now they are able to maintain the privacy they desire because they don't want to make their data directly available to the large language model. They instead say, if you want to interact with any of our data, go through our server. We will determine whether it's applicable to go and fetch our data, what data we need to give, and what we're ready to accept as an LLM request. And this way, the restaurant is able to maintain its privacy. And the LLM also doesn't have to worry about all the new tools. All it cares about is any tool it has to interact with gets sent to an MCP server, which handles the routing to different tools and different use cases. And so what we've really shown here through this diagram and architecture is that by having both the MCP server and the standardization of these tools, we are able to allow scaling to multiple agents because now the LLM won't get confused and no longer itself has to handle the extra load of these extra agents. This is handled in a decentralized way by the providers of the APIs themselves. So now whether it's a restaurant, a flight booker, a blockchain analyst, they all host their own agents and basically make these available in a standardized and easy to understand way to any LLM provider out there. And that's great. And that's very much aligned with how the whole crypto space is moving as well. We want this decentralization. We don't want to rely on one centralized source controlling everything. So how is this relevant to Chatoshi, our product? So it's not done right now. In Chatoshi, we have what we call centralized agents. So we've built many agents in-house, which we think cater to the use cases and needs of the crypto community. And these are growing every day. But we also realize that, as was being mentioned before, we can't cater to every niche use case. But there may be creators or providers or companies or clever people out there building agents to do this. So we are looking to build our own kind of MCP server kind of access to anyone to interact with our architecture, but provide access to their bespoke APIs and use cases and data, which they can keep private without having to give to our system. So this is something not in the works right now, it's in the roadmap. I think this is very aligned with how the entire AI community is moving as a whole, including like OpenAI, Claude. And I think this is something going to be standardized in almost every product, probably by 2026. So people say 2024 was a year of retrieval augmented generation, 2025 is a year of agents, 2026 I would say is a year of MCP. You can hold me to it. Okay, so in this presentation, what we've covered is two exciting things we think are coming out of research. One is model steerability. Two is MCP. So do look out for these things in AI and also give a go at trying out our Chatoshi product by scanning these QR codes. Thanks everyone and open to any questions.
Thank you, Vyas. Do we have any questions on scaling AI systems, agentic flow or Chatoshi directly? Maybe some questions on how to raise funds because guys also successfully raised and they know some alpha.
I guess.
Okay, if we have no questions, feel free to network, enjoy some pastries. We ordered a really nice pastry from Artisanal Bakery, so please feel free to treat yourself. And thank you, Vyas. Thank you, Vatsal, Piotr, Alex, everyone. Feel free to follow Chatoshi, Hero, Apta, and Simplicity Group on social media. Come to our events and have a nice token week. Thank you.
Web3.